Let's get right to it. Machine learning is very process-oriented. All projects follow the same core steps. You're given something to predict. You source the data for your model, you cleanse that data, you model it, you tune that model, and then you put that model in production. The first thing I look for when I'm looking for any contract in machine learning is the location of the data. If the data isn't a structured data store, like a relational database or a data warehouse, I'm not interested. If you think working with structured data is hard, try scraping website data and then modeling it. I'd rather have a root canal. After I'm given access to the data store, I need to author the query, or lots of queries, to pull that data into a data set. That means I need to learn how the tables are related in order to create the joins for my query. The data you need is never in one table. It's often in 10 or more tables, and you need to write the code for that. Okay, I've written my SQL code, and now I export some of that data I've amalgamated into another table in the database. I don't need a lot of it right now. A few thousand rows to start with is good. Once I have the data in my own table, I need to add a target variable to it. Let's say that I have a data set and I'm trying to predict dogs from cats. Now, these aren't images. These are simply data points specific to each animal. Since this is a binary classification problem, I create a column called target variable and put a 1 for dogs and a 0 for cats. After that, I export a few thousand rows to a CSV file for data cleansing, modeling, and tuning. I use Pandas to pull the data into my Jupyter notebook and work through my data cleansing framework there. Once the data is cleansed, it's on to modeling. Almost all my models, actually all of them, use gradient boosters because it's the top model for regression and classification problems. I use XGBoost locally and then AutoML tables for my final builds. That means on my laptop, I'm using XGBoost to build my model to get an idea of the performance I'll see later. I'll use AutoML for the final build because nothing beats its performance. Now that the process has been worked out on my laptop, I need to apply those same steps to a much larger data set. How I do that will depend on how much data I have. If I only have a few gigs of data, I can probably get away with doing that on the data store in-house after hours. However, if I have a ton of data, then I'll need to put that data somewhere that can handle the cleaning and modeling at scale. I like to use BigQuery for all my large models. This is a Google data warehouse. It's like one big table. The hard part will be taking the data from on-prem and uploading it to BigQuery. This is a pain in the butt. You need to break up the data or use a third-party tool to get your data up there. It's not a lot of fun. It's not hard, it's just time-consuming and tedious. However, once my data is in BigQuery, I simply upload my Jupyter notebook, the one I was using on my laptop, and point it to the data located in BigQuery. The data is stored in such a way that I don't need to worry about how much I have. I can model any size dataset with BigQuery using the same process I did on my laptop with a few thousand rows. Alright, last step. I've cleaned my data, I've created the model, I've tuned that model, and now I'm ready to put it into production. Most of my models are batch. That means I feed a lot of data into my final model, and it gives me some metrics for each observation or row. Once the batch results are completed, I then put that in a folder the business can access it, or I give them access to the results in BigQuery. That's my machine learning process for most of my models. Thanks for watching. Don't forget to like and subscribe, and have a great day. We'll see you soon.